Hey, what's going on, guys? GoMikeAgainst here. In this video we're going to be sorting our principal variation moves. So the idea behind this is that every next depth within the iterative deepening framework we're hitting, we would be reusing the moves extracted from the principal variation table that is available from the previous iterations. So we would be extracting those moves from that principal variation line and apply the moves from that line within the current iteration, so that they would be ordered first in the move list and they would be searched first. So the best move from the previous iteration would be searched first in the next iteration. That's the simple idea behind the move ordering technique called sorting PV moves. So without further ado, let's actually dive into a particular implementation, and I'll try to provide some explanations along the way. And generally, the idea behind this particular implementation is taken from the TCP chess engine by Tom Kerrigan, with some minor changes to fit the implementation of BPC, the chess engine we're currently working on. So as far as I'm not scoring moves within the add move function, as far as our moves don't really have scores, we're just assigning them later on, and also assuming that we're sorting moves not on the fly within Lupo with the moves in the Nigamax search, but instead just separately before this, just to make this process more modular. This this brings a need of one extra variable to score our principal variation moves, called score PV flag. But generally the idea is absolutely the same. I mean, just the implementation would be slightly different compared to how it's made in TCP, but the idea is absolutely the same. Okay, so without further ado, let's actually start. So first we need to define a couple of global flags to answer two questions. So first is the follow PV, and the second is score PV move. So I create the variable called follow PV, just like TCP does. So this variable flags if we are currently following the principal variation line within our search or not. So if we do, then this flag is equal. If this flag is equal to 1 or true, then we do follow the principal variation. If it is equal to 0 or false, that means that we don't follow that. That's it. And another flag is the score PV that would be changed accordingly. So by default, the global variables in C programming language, assuming the GCC compiler, are initialized to zeros. So that's another idea to have in mind. And now let's go to our search position, and one of the important things to consider, we want to set this follow PV equals to 0 and also score PV equals to 0 every time we're making a new search. So we want to reset, let's say, follow PV flags. So follow PV would be equal to 0 and score PV would be equal to 0 as well. Okay, and also, well, let's do this here. Okay, just for our comparison search. Okay, so it seems to be like this is it. Okay, and now the very first thing to do within the iterative deepening, I'm not counting this node equal to 0 because I would get rid of this as soon as I'll demonstrate how the nodes are getting saved thankfully to the principal variation moves ordering. So here we want to enable follow PV flag, and we just say follow PV equals to 1. Okay, And now we need to go to our Nigamax search. So within the Nigamax for search, just right after we've generated the moves and before we've sorted the moves, we need to do the following thing. So if the follow PV flag is enabled, so if we are now following principal variation line, in this case we want to enable principal variation move scoring, move scoring like this, and I want to call the function enable principal variation scoring like this, and it would be taking the move list as its argument. And now we need to implement this function, so let's go up to the score move here, and this would be the static inline void function called enable PV scoring. Okay. Yeah, just what it is actually, enable principal variation move scoring. And here, the very first thing to do, we need to disable following principal variation, because so follow PV equals to 0, because once we've hit this, we're no longer following the principal variation. It's quite pretty simple. And the next thing to consider, we need to loop over the moves within a move list. So for int count equals to 0, count is less than move list, and count plus plus. Now here we need to make sure we hit principal variation move. So in order to do this, I can simply say if, and I'm referencing the principal variation table, the current final principal variation line, the first index of 0, and the second is indexed by the current fly, so depending on depth. So if it is equal to move that, if there is a corresponding move within the move list, so move list moves and indexed by the count. In this case, we actually want to do two things. So we want to enable move scoring. So I just set the principal, I just set the score PV equals to 1, and also we want to enable following principal variation, because if we do find this move in particular, we are actually in the principal variation, so we need to enable this. So I just say follow PV equals to 1. Okay. Let's actually try to compile and run the code to make sure it has no errors. So make debug, and if it makes, I want to run the BBC binary executable. Excuse me. Oh, move list. So it should take moves pointer to the move list. Okay. Okay, and the very last thing left here is, well, I don't really need the search now, is actually to provide the logic of scoring the moves. So if if principal variation move scoring is a load, So I say if score PV is allowed. In this case, again, like we need to make sure we're dealing with principal variation move. So here I can say if, and again I'm referencing the principal variation table, so PV table indexed by 0 and by the current ply is equal to move. So the idea is, well, in THCP the move is getting scored right over in here, but as far as the BBC doesn't have an option to score the moves, because move is just an integer, it doesn't have a score. That's the reason. That's the reason for just enabling the flag to score the principal variation. And if this flag is actually available, we need again to make sure that we're dealing with exactly the principal variation move, because the move that is getting here is actually the move, one of the moves from the move list, and this loop is done within the sort moves, if you remember, right over in here. So we're just trying to score every single move we have. So we're passing moves one by one, and in case if scoring the principal variation is available, we need to make sure that this is actually the move. Well, it's a little bit of duplication, so we first do it here and then do it here, but assuming the implementation, this is necessarily needed. And in this case, we want to score principal variation move. So give let's say give principal variation move the highest score to search it first. So I want to return the score of 20 thousandths. So this is just like here we have 10 thousandths for captures, and we would be having 20 thousandths for principal variation moves. But for now, I just disable this. And one more little thing here. So I need not to forget to disable score PV flag, because otherwise it won't be working correctly. So I just need to say score PV is equal to 0, like this, and return this to thousandths. And also, just for the debugging purposes, I just want to print the principal variation move. Well, let's say current principal variation move, and then I want to print move that we have, this move, and also I want to print the corresponding ply. So ply and the ply here. And if I did everything correctly, it should now be picking up the best moves on the corresponding ply from the previous iteration, and it seems like you do this. Okay, so let's have a look. So at the depth of 1, so initial search, we don't have anything here because we didn't yet retrieve any principal variation moves. But here, when we're going for the search at the depth of 2, we already have the move e2 e6 from the previous iteration. So here is the move, and we are scoring this. Well, we're not yet scoring it. I'll just enable the scoring to give you an idea how the nodes are gonna get reduced after, but just to give you an idea first. So now we need to take this move, and when it comes here, we just need to score this, give this move the highest score to search it first, and hopefully to produce some beta cutoffs later on. And this is the only move available. So when it comes to the next ply, it doesn't have an idea like what move to put there, because there is no corresponding best move from the previous search. But now if we go to the depth of 3, again we can score the first move. And by the way, if this move would change somewhere along the way within the search state, would find a better move, this move would be replaced already, which is also a good consideration. But then when it comes to scoring the next ply move, it appears that we already have the best move from the previous iteration, and this means that already the depth of 3 we would be scoring this move as the first, regardless whether this is a capture or quiet move or whatever. Just because this is the best move from the previous iteration, we would be scoring it first, and so on. So the more nodes we actually have, okay, I'm just wondering. Oh, it just still prints some. Okay, it just still prints some notes after. Okay, anyway, so let's actually try to enable our scoring, and if I did everything correctly, this number should reduce from 43 thousandths to 30 thousandths. So about like that. So let's try to return the score of 2 thousandths. And this should give a last number eventually. Yeah, and this is what I wanted to prove to you guys. So without this, without ordering principal variation moves, we have this number of nodes traversed. But when we do apply our principal variation, we have a last number, which is quite pretty interesting. So from the previous iteration, yeah. So this is it. So you can see the results. I'm just, well, now it has printed correctly. Oh yeah, that's because the return itself wasn't really available. This wasn't available. So yeah, if I just return, oh no, if I return 0, it would be, it just smashed the results. Okay, so let's probably drop it like this. Try to run again. Yeah, now it works. Yeah, now it works. Because I just was wondering why these nodes were here. Yeah. So when I return the best score, it's getting fixed. Well, okay, guys. So you know, like, I'm really sorry for my own vague understanding of this process, and I'm now after the move generation process ended, I'm now in the unknown territory, basically. And you know, like, the way I was doing principal variation move scoring in my previous attempts, including, by the way, the demonstration of BBC playing to the depth of 9. There was a horrible bug there. What I did was a weird stuff. I just was returning 20 thousandths every time when we find this move, without searching for this score PV, testing the score PV flag. I didn't even have that flag. And in this case, it actually makes search even slower, because it just started doing some weird stuff. And I didn't even realize that was happening until started recording this video. So, you know, like, recording this video really helps to reveal this, like, bugs that you probably won't see that fast otherwise, because you're not getting that deep into it. And also, I just you know, like, the problem in chess programming world, the problem is that those guys who are really smart and really know exactly how to do these things, and who can explain this in great details, the most thing that they can do is just give you an extended answer in talkchess.com. But and I did actually I do ask some questions there from time to time, but unfortunately it happens quite pretty often that when you're getting a question, well, I don't know, like, me personally, I'm really bad at understanding what I read, and my understanding is way better when I when I'm watching the video. That's literally the method that I'm using to learn whatever new thing I want to learn. So the problem is that those guys who really knows these things in a great details, who has like 30 years experience of chess programming, unfortunately they're not producing videos, and they only give these textual explanations, which for me personally it's incredibly hard to understand what they mean. What I can say from my own experience, like let's say I got an answer from a guy like 2 years ago, and I just can save that answer somewhere in the text file on my computer, and like I didn't understand anything from that question in that time, and then I was practicing for chess programming for 2 years, and then suddenly, eventually, when I got some experience, I've started realizing the reasons behind that 2 years ago answer. And if I reread this answer again, it would start making some sense to me. But it took me 2 years to. It would take me for about 2 years to get my own experience to realize like what exactly that answer kind of meant. So the questions I'm getting now at talkchess.com would probably be understood by me like a couple of years in the future. So that's kind of it. So I'm really sorry for I don't really have that great understanding of how things works. But good news is I'm not the only one who don't have that clear understanding. So fortunately, there are lots of people who don't know exactly this kind of sort of things, and this is really complicated. And by the way, you know, like the matter of the strengths of your chess engine is not even the matter of your coding skills, but instead it's more like the matter of understanding the greater details of the inner processes that are happening within the chess engine regarding every single part in particular. So when you have a vague understanding, you have a vague implementation, and mostly it contains lots of bugs that you have no idea about. And you can reveal those bugs only when your understanding will grow, and only in that case you will suddenly realize like, oh my god, I got a bug here, like why didn't I see this before? Because you didn't even know where to look at. That's the reason. That's what's happening to me now, guys. So the idea behind this videos is actually to show you the process of my own progress, and hopefully I would be really happy if you would be progressing along the way with me here. And that's another reason why to keep going, developing this engine again, like further and further on, because otherwise, me personally, not gonna learn anything. So I'm learning by doing things, and you know, like if it comes to some sort of a bug or something, doing something wrong, I need to do this wrong thing like really hundreds of times, and only then I will realize that I was doing something wrong. And actually, one last thing I want to say here. Sorry for being a little bit off topic, but I just don't really want to make a separate video on this. But at the same time, I have something to say. So there are kind of two different approaches that I've encountered on Talk Chess forums. So most of the guys there go in the following way. So they first need to understand what exactly they are doing, and then they go to the implementation. And Code Monkey Kings like me go in absolutely the opposite way. So we Code Monkey Kings, we're trying to find a straightforward, the most easy and the most straightforward implementation to take somewhere, and the one that is easy embeddable into our own source code. Then just try to make it work, and then later on, maybe years would pass after, then later on Code Monkey Kings like me started finally to realize and to understand like how in particular that was actually working. So I want to say that those techniques I've taken from TSCP to collect principal variation and to sort principal variation moves, I don't yet have 100% of understanding of how in particular they are working. I understand, I don't know, probably for about like 50 or 60%, no more than that. And that's the reason why I can't explain this myself in that great detail. So when you guys asking me like in the commentaries, so I'm not always capable of giving some professional answers. So if you want some professional answers, it's better to go to Talk Chess forum. but there is the only problem there. So if you are capable actually of understanding those questions, then you don't really need to ask those questions in most cases, because you will be able to dig it on your own and find the answers on your own. And in case if you can't do this and you are forced to ask these questions, then most likely you won't understand the answers that you would be getting there. So for me personally, the matter of growth as a chess programmer and the matter of making your chess engine stronger is just the matter of practicing. And the more you practice, the more understanding you're getting eventually. And I promise you guys that later on, when I will get a more clear understanding of techniques involved in this past two videos, one day when I realize, when I would be kind of 100% sure how they works, I will definitely make a video explaining this again, well, probably separately from the chess engine development progress, but still. And I feel like I'm accumulating this like topics to cover later on. Okay guys, so this is it from my side. Sorry for talking for too long, but just I just want to be crystal clear with you and to show you how it works on the real deal. So when it was like about the mood generator, I do understand what's going on there, and it relies on my own implementation. I'm not reusing someone else's code there, because when I say like I've been doing chess programming for 5 years, it's more honest to say I've been doing mood generator programming for 5 years. I've never been doing search that deep before. So like all experience I had with the search ended up with sorting MVVLV, history, and killer moves, and that's it. So I was thinking that I know how to sort PV moves, but yesterday I realized that the way I was sorting PV moves was actually making the engine slower, which is absolutely completely disaster. Okay guys, so I hope that these insights are not gonna force you to live in the series, and I really hope that you will still be following this, because at very least what I can guarantee from my side is that the implementations I am embedding into this chess engine are actually working, and we need to see like the power, like the strength of the chess engine is the fair measure of answering the question whether we're going the right approach or wrong. Because if you're doing something wrong, your engine would be slow and weak. But if it's getting faster and if it's getting stronger, that means that the overall direction is kind of right. And then when we'll provide some basic patterns into it, and when all the bricks it's built out of would be completed at some stage at least, then we would be able to take every single brick in particular and dive deeper into that, and like try to get a more concrete understanding of how things are working. Okay guys, so this is it from my side. Thanks for watching. Hope to see you in the next parts within this series of Bitboard CHESS Engine in C. Until that time, and take care.